Okay, so we've got the mock paper 5. This was the higher non-calculator paper. So away we go, straight in with standard form. So we've got to do 2 times 4 times 10 to the power of 3 times 10 to the power of 4. The 2 times 4 is 8, and the 10 to the power of 7, because when we're multiplying things with powers, if it's the same base, then we just add the indices. Okay, and that is important going on to question 2. We've got to simplify fully. 3a to the power of 8 times 2a to the power of 5 all over a squared. Let's simplify our numerator first of all. 3a to the 8 times 2a to the 5 is going to be 6a to the 13, and we'll be dividing that by a squared. It's because we multiply the big numbers, we add the powers to get a new power. When we're multiplying, this means division, so we're going to subtract powers. We end up with 6a to the power of 11. Okay. And then part B is a solve. First of all, we're going to break into this fraction. We're going to get rid of that by timesing both sides by 5. That will leave us with 6x minus 10 equals 5. Then I'm going to get the x's by themselves, so I'm going to get rid of the minus 10 by adding 10. And then I'm going to work out what 1x is by dividing by 6. Leaving it as a fraction is not quite good enough. We will either have to simplify, turn it into a mixed number and simplify, or write it as a decimal. 2.5 is the final answer, or 2.5. Okay, then we are on to Ed has a card shop. He buys a particular card for £1.20 and sells it for £1.68. Calculate his percentage profit for the card. Well, the first thing I'm going to do, £1.20 is 120p. I don't want to work with decimals, I want to work with whole numbers. £1.68 is 168p. Okay. The next thing that we're going to do is we are going to work out how many pence profit he made. So that's done by doing 168, take away 120, and we get 48p. That's the profit. Okay. Now, if we want that, calculate the percentage profit that he's got, that's 48 out of 120. We want to turn that into a fraction that's out of 100, or we want to do 48 divided by 120 times by 100. All of these ways will get us a percentage. If we divide by 12, then we will get a fraction that's out of 10. 48 divided by 12 is 4, so 4 tenths. If we want that as hundredths, it would be 40 hundredths, and 40 hundredths is 40%. Part B. Ed's profit on good luck cards in 2018 was £360. This was a decrease of 20% on his profit from 2017. So we've got 2018 was profits of 360, and 2017 we're going to want to work out. We know that wherever we start, which is 2017, is 100%. The reason why we're starting in 2017, we're going back to there because his profits were down 20% on 2017, so that means they're 80%. Okay. So what we've got to do, 360 divided by 8 will give us 10%, and if we're going to do division by 8, we end up with 45. So I have to think about that quite carefully. And then we're going to multiply by 10, which will get us back up to 100%. So he made £450 profit in 2017. That's 10%. 100%. Okay. Then question 4a. A sunflower grows at a rate of 4 centimetres each day. How many days does it take to grow from a height of 80 centimetres to 1.06 metres? 1.06 metres equals 106 centimetres. We need to find out how many centimetres it has grown, how many days it's been growing for. So if we do 106 take away 80, this is how many centimetres it will have grown, which is 26 centimetres. And then if we divide that by 4, because it's growing at 4 centimetres a day, we will work out how many days it is. Now 26 divided by 4 isn't an exact number, it's 6.5. So we need to round that up. It's going to be 7 days is our final answer, because it could have done all its growing during the day, and if the first half of the day was night, then it's not going to have grown anything in 6.5 days. Or it's not going to grow the bit that it would grow by 6.5 days. If the sunflower grows at a faster rate, how would this affect your answer to part A? It would reduce the number of days. Okay. Moving on to question 5. Okay. The table shows the ages and values of 11 cars of the same model. The first 7 points of the first 7 cars are plotted on the scatter diagram. Part A. Plot the remaining 4 cars. Okay. So I can't quite fit this all on at once, but we are going to have to plot a car aged 3 years with a value of £8,000. So years along the bottom, that's going to be there, 3, and then 8,000. Okay. Then our next car is 7 years and 5.6 thousand. 7 years is easy enough. The 5.6 thousand, well, this would be 5. Each of our little squares is 0.2, so that's 5.2, 5.4, 5.6. And then our next one, 8 years and 5,000. 8 years, 5,000. And then the last point, it's got a few people, 12 years and 0.4. So 12 years, and then it's just 2 little squares up, because each little square is worth 0.2 thousand. Okay, then it says, describe the type and strength of the correlation shown in the completed scatter diagram. It doesn't want you to describe what's going on, it just wants you to tell, they just want you to say that it is a strong negative correlation. It's not weak. The reason why it's not weak is there's an outlier which confuses some people, but actually all of the rest of the points are fairly close to being in a straight line. Okay, so strong negative correlation. Okay, one car lost its value more quickly than the other cars. On the scatter diagram, circle it. That's our outlier there. By drawing a line of best fit, estimate the value of a car that is 6 years old. So we just want to get a line that roughly goes through the centre of all these points there. I'm going to ignore the outlier. That'll do. And it was a car that was 6 years old, so we're going to find 6 on our age. Draw a line straight up till we get to our line, and then horizontally to our value. And that's going to be 6.4 thousand. So we either need to put 6.4 thousand or 6,400. 6.4 won't do it because the car's not worth £6.4. And explain the limitations of using the equation of line of best fit to estimate the value of a car that is 16 years old. The line of best fit would imply the car has a value less than £0, and this is not possible. Okay. Question 6. Ooh, nice probability question. A bag contains 4 red counters and 3 blue counters only. Jack picks a counter at random and then replaces it. Jack picks a second counter at random. So each time he's picking from the same 7 counters. 4 in 7 chance of it being red, 3 in 7 chance of it being blue. And because he replaces his counters when he goes for his second pick, exactly the same. 4 in 7 red, 3 in 7 blue. There we go. So we have completed tree diagram. Work out the probability that Jack picks 2 red counters. So we're looking for probability of red and probability of red. You won't need to write this bit. This is just to help me explain. Our probability of red is 4/7. And when we're talking probability and, means we multiply them together. 4/7 times 4/7, 16/49. That is your final answer. And question 7. Adam buys some tickets in a sale. The normal price is £80 for each adult and £40 for each child. In the sale, the prices are reduced by 15%. Adam buys 2 adult tickets, 1 child ticket at the sale price. A 2% booking fee is then added to the total cost of the tickets. Calculate the total amount Adam must pay. So what I'm going to do is I'm going to work out the normal price for what he wants. That's going to be 2 times 80 plus 40, because that's 2 adults and 1 child, which comes out at £200. Sale price. Well, £200, 15% of £200 is going to be 30. So our sale price is £200, take away £30, £170. Okay. Now we need to add on the 2% booking fee to get our final price. So 1% of £170 is £1.70. Therefore 2% is going to be double that. That's £3.40. So our final price is £170 plus £3.40, £173.40. Put that on the answer line so that the examiner knows that's exactly what we want.